Ever wondered how a self-checkout machine knows when something is not right? You scan a chocolate bar, place it in the bagging area, and somehow the machine instantly knows whether you actually scanned the item, placed the correct item, or tried to sneak something through without paying. Today on Knowledge Hub, we are going inside the technology behind self-checkout machines and how they use scanners, weight sensors, cameras, artificial intelligence, and stored databases to detect mistakes, suspicious actions, and possible theft. The first layer is the barcode scanner. Every product has a barcode, usually a UPC or EAN code, which is basically a machine-readable product ID. When you scan it, the checkout system sends the code to the store's POS database, which stands for Point of Sale System. The database then returns the product name, price, tax category, discount rules, and sometimes even the expected weight of that item. So when the screen says, milk chocolate bar, the machine is not guessing. It has matched the barcode to a specific SKU, or stock keeping unit, inside the retailer's inventory system. But scanning alone is not enough, because someone could scan one item and place another item in the bag. That is where the second layer comes in, the bagging area scale. Under the metal platform where you place your items, there are load cells, which are sensors that convert pressure into an electrical signal. The machine already knows the expected weight range of the item you scanned. So when you place it in the bag, it checks whether the weight increase matches what it expected. If you scan a packet of gum but place a bottle of shampoo, the weight difference is too large, and the system may stop the transaction and ask for assistance. This is why self-checkouts sometimes say, unexpected item in bagging area. It does not mean the machine is angry. It means the actual sensor data does not match the transaction data. Modern systems also use tolerance ranges because real products do not always weigh exactly the same. Packaging can vary slightly, produce can be different sizes, and customers may place bags unevenly. So the system does not look for one perfect weight. It checks whether the weight is within an acceptable range, but some items make this harder. Think about fruits, vegetables, bakery items, or loose goods. They may not have barcodes, and customers often need to search for them using PLU codes, which stands for price lookup codes. This is one of the biggest weak points in self-checkout, because people can accidentally select the wrong item or intentionally choose a cheaper item. That is why newer machines are adding computer vision and AI. Companies like NCR Voix and Toshiba describe systems that use cameras and deep learning to recognize fresh produce, reduce item misidentification, and improve loss prevention at self-checkout. Instead of depending only on what the customer selects, the machine can look at the item on the scanner scale and suggest whether it looks like bananas, apples, onions, or another product. Now comes the most advanced layer, behavior detection. Some newer self-checkout systems use cameras near the scanner and above the checkout area. These cameras are not just recording video for a security guard to watch later. In advanced systems, the camera feed can be processed by AI models, sometimes directly on edge hardware inside or near the checkout machine, so the system can react immediately without waiting for a cloud server. Toshiba describes this kind of edge camera setup as using neural networks to monitor customer behavior and trigger self-checkout software interventions when potential non-scanning happens. The AI looks for patterns like an item passing over the scanner, but no barcode being read, an item going straight into the bagging area, or a mismatch between what was scanned and what the camera sees. Fujitsu also describes systems that can detect scan avoidance and compare the scanned barcode with the actual visual product to prevent barcode swapping. But here is the important part. Self-checkout machines do not truly know you are cheating the way human knows. They detect anomalies. An anomaly means something does not match the expected pattern. Maybe you forgot to scan an item, maybe the barcode did not read properly, maybe the bagging scale made a mistake, or maybe someone is trying to cheat. The machine does not immediately accuse you. It usually creates friction, a warning message, a pause, a rescan request, or an alert for a store attendant. This is called exception handling. The goal is to stop losses without making honest customers feel like criminals. And this matters because self-checkout has created a real challenge for retailers. Some chains have even reduced or removed self-checkout in certain stores because shrink, which means inventory loss from theft, errors, damage, and process problems became too costly. Dollar General, for example, cut self-checkout from thousands of stores in 2020 as part of its effort to reduce inventory losses. So the future of self-checkout is not just faster scanning, it is sensor fusion. Barcode data, weight data, camera data, payment data, product databases, and AI models all work together to build confidence that the transaction is correct. When everything matches, the checkout feels smooth and fast. When something does not match, the system slows down and asks for a correction. So next time a self-checkout machine tells you there is an unexpected item in the bagging area, remember, it is not magic. It is a small network of scanners, load cells, cameras, databases, and artificial intelligence all trying to answer one question: does what the customer scanned match what actually happened? If you have enjoyed this deep dive, don't forget to subscribe to Knowledge Hub for more videos that explain how everyday technology really works, and as always, stay curious.